Let's look at the 8th problem type. This says find the concavity and point of inflection. And we got f of x is equal x to the 4th minus 12x to the 3rd plus 48x squared minus 64x. Now, first step is we're going to find concavity first, so you have to find second derivative. So we'll find our first derivative. That will give us 4x to the 3rd minus 36x squared plus 96x minus 64. Remember, take your power, put it out in front, lower your power by 1. Here, take the 3, put it out in front. We got 12 times 3 is 36. Here, 2 times 48 is 96. Second derivative. We just take the derivative of the first. Take your power, put it out in front, lower it by 1. Minus 72x plus 96. Now, we need to find our critical values, so we set our second derivative equal to 0. So I got 12x squared minus 72x plus 96 equal to 0. They all are divisible by maybe 12, definitely 6. Let me try 12. So that gives me x squared minus 6x plus 8. Well, now I can, that was GCF there. Now I can use the Psd method to factor it. And this factors as x minus 2 times x minus 4. Now I'm going to set these equal to 0, but it doesn't do me any good to set the 12 equal to 0. So I just set the x minus 2 equal to 0 and the x minus 4 equal to 0. And we get 2 and we get a positive 4. So these are our critical values. Well, I want to build a table of intervals. Clear over here is negative infinity. Clear over here is positive infinity. I want to pick test cases. Pick x values between negative infinity and 2, like 0. Pick a value between 2 and 4, like 3. And pick one greater than 4, like 5. And these are our test cases. We then want to plug that into our second derivative and see what our sign is going to be. Now, probably the easiest one to plug it into, you could plug it into this one. That wouldn't be any problem. But this is the same thing just factored. And this is actually easier to plug it into. Now, the 12 we don't need to worry about. I can drop that. So the only one we're going to worry about plugging it into is x minus 2 times x minus 4. And same here. X minus 2, x minus 4. Now the reason why we don't worry about 12 is all we're concerned about is the sign. We don't care what the value is, just what the sign of the answer is going to be. Well, 12 is positive, so it doesn't really affect it at all. Now if I put 0 in here, I got 0 minus 2 and 0 minus 4. Negative 2 times negative 4 gives us positive. So this is positive, which means it's concave up. If I put 3 in here, 3 minus 2, 3 minus 4. 3 minus 2 is positive, 3 minus 4 is negative. Positive times a negative is negative. So this is concave down. Again, we don't care what the value is, we're just trying to see what our sign is going to be. And if I put 5 in, I got 5 minus 2 and I got 5 minus 4. 5 minus 2 is positive, 5 minus 4 is positive. Positive times a positive is positive, so this is concave up. Now, our concavity goes like this. It's concave up from negative infinity to 2. I'm looking at my critical values and my infinities up here. And then in this interval, it's concave down. So it's concave down from 2 to 4. and then it's concave up from 4 to positive infinity. And that's my concavity. Now, our point of inflection is where the concavity changes. See how this is concave up and this is concave down? So this would be a point of inflection here at x equals 2. Now this is concave down and then it's concave up. So this will be a point of inflection at x equals 4. Now they wouldn't be points of inflection if it didn't exist at those. But what we're dealing with here is a nice polynomial. So I know it's going to exist there. So our POIs, our point of inflection, is going to be at x is equal to 2 and x is equal to 4. Now, points of inflection, that means they should be a point. So we need to plug those values back into our original function and find the y value. And I'm not sure if I left enough room there. So, our original function, we got f of 2 is equal to 2 to the 4th minus 12 times 2 to the 3rd plus 48 times 2 squared minus 64 times 2. 2 to the 4th is 16. 2 to the 3rd is 8 times 12 is 96. Here we got 48 times 4. I have no clue what that is. 192. Yeah. Minus 128. So that gives us what? Negative 80. And this is assuming I don't screw this up. I should plug in my calculator, but that's 64. Sixty-two, 64, yeah. And that gives us negative 16. Yeah, negative 16. So that would be 2, negative 16. Okay, I want to show one by hand. You can also use a calculator to do this. Very nicely, it does it. If I go to my y equals, do clear, and I want to put in my original function, the x to the 4th, so x caret 4, minus 12x to the 3rd, plus 48x squared, minus 64x. Now I want to go to table set. If I do second window, that'll go in my table settings, or table setup, I guess I should say. And you see where it says independent? You want that to say ask. So if it doesn't say ask, down arrow to it, and right arrow, and have your flashing cursor on the ask and press enter. Now I exit out to a second mode, and now if I go into table mode, if I do second graph, well, now we can plug in those values directly, like 2. If I put 2 in and press enter, I get negative 16. That's correct. If I put, what's my other one? 4. If I put 4 in and press enter, 0. That's weird. I believe it, but 4, 0. So that's our point of inflection, and this is our point of inflection.